Hello everyone. Today we'll perform the next experiment, which is common source JFET amplifier. This is the circuit diagram what we had plotted in LT-Spice, and this is the output what we are obtaining. Input waveform and output waveform is inverted. When you see at the working of the common source JFET amplifier, initially when the input is applied, if this is the input positive half cycle, then as we know that it is a n-channel JFET, and the gate is connected to VGS, gate to source voltage. So initially when the positive half cycle comes, then we say that the depletion region is initially less. So when the depletion region width is less, then the channel width is more. When the channel width is more, the current flow through this width through this channel is more. So therefore, when the current flow is more, then we can see that here is where ID flows, ID, RD, ID flowing through RD. So when ID is more, we see that in this equation, VDD is normally constant, which is shown here. VDD is normally constant. When ID increases, then this term increases. As this is constant, VDS reduces. So increase in drain current will reduce the drain to source voltage. This VDS is reduced. So therefore, we see that we'll get a negative half cycle, amplified negative half cycle in the output side. In the next case, when VGS is reduced, so what happens when it is more negative, then the depletion region width increases. So when the depletion region width increases, we can see that the channel width is narrowing. When the channel width narrows, the current flow through this is reduced. When ID is reduced, this term is reduced. As this is constant, VDS is increased. Okay. So therefore, we can say that when the negative half cycle comes at the input, the output is inverted and it is increased and amplified. So therefore, we can say that this common source JFET amplifier is simply a inverted amplifier. It means when the input is a sine wave, we will get a inverted sine wave at the output, and which is amplified. This is about common source JFET amplifier. Thank you. Okay, so now we'll see how we'll perform this one in LT-Spice. We'll simulate it in LT-Spice. I've already drawn the circuit diagram. So we have two sources here. One is for VDD and this is VGS. We have three coupling capacitors, and this is the potential divider circuit, and this is the load resistance, and this one is the JFET. So to select this one, we have to go to component and we have to type in NJ. When you type in NJ, we'll get this NJF. You have to select this one. Okay. So after selecting this one, right click on this and pick new JFET. Here you will get 2N3819. This I have selected. I have taken here. And apart from this, all other configurations, all other values, what we have given is the voltage source value. DC offset I have taken 0, amplitude 1, frequency 55 Hertz. C1 I have taken 0.47 microfarad, C2 10 microfarad, C3 40 microfarad. R1, R2, R3 I have taken common 1K, and R5 I have taken 100. This VDD I have taken 16. Okay, and once you run this, I'll take two plots, one for input and one for output. You can see input is which is shown in this green color wave, and this is the output. Okay, you can see output is inverted. Thank you.